Hello everyone, here's a video on limiting reactants, the concept and the calculations behind it. Okay. Alright, so in a limiting reactant problem, it's exactly what it says it is. It's the reactant that is completely consumed or consumed first, thus shutting off the reaction. So in a perfect world, every reaction would have what's called a perfect stoichiometric ratio. You have just as much of one reactant as you do as the other, and they both get consumed at the same time, and everything is done, and it shuts off. But that's not really the case, okay? So for example, if I were to have a campfire in the back, and I have like 5 logs, and I'm going to burn those, when will the reaction stop? Not in time, but when will the reaction stop? It will stop when the logs are all done burning. Okay, the other reactant is oxygen. I have a ton of leftover oxygen, obviously. We hope that one small campfire won't deplete the oxygen in the environment. But that's the idea here. So when does the reaction stop? When the limiting reactant is completely consumed. Okay, so it limits how far the reaction can proceed and how much product will form. And all we do is follow the steps of stoich. Okay, so we're going to modify just a little bit here. So if we have this particular reaction, and I'll do one problem because they all work exactly the same. We have a reaction of H2 plus O2 yields H2O. And it says I have 150 grams of hydrogen and 1,500 grams of oxygen gas. What mass of water can be formed? So before you start here and say, oh, you only have 150 grams of this must be your limiting reactant. This is definitely the smaller amount. And 1,500 grams of oxygen, well, that's definitely the most. Before you do that, let's get some numbers here with moles. Okay, that's why we got to work stoich here. So these numbers, 150 and 1,500, can't be misleading. Okay, don't take a guess there. Okay. So the first thing is how do we recognize that we have a limiting reactant problem? They give us stuff about they give us information about reactants. Okay, 2 or both reactants. Okay, sometimes there's 3 reactants. Most cases we just have 2. So notice I underlined and circled in red and underlined and circled in green. Okay, so those are the two. You get 2 numbers, and they refer back to the 2 reactants that are listed. That's how you recognize a limiting reactant problem. Now, how would you say with stoich? Stoich, they only give you 1 number, and you can convert to anything in the equation. It could be anywhere in the equation. You convert to anything in the equation. Okay, so what we need to do is just work our stoich. Okay, but now we need to do it twice. Okay, and there's 2 methods to do this. I'm going to do it the following method. What I want you to do is convert both of your reactants to the same product. Well, there's only one product to pick from, and that's water. Okay? If there was another product, again, it doesn't matter which one you pick. Just make sure that you calculate moles of both the reactants to that same product. Okay? So, 150 grams of H2. The molar mass of hydrogen is 2 grams. Convert that to 1 mole. Oopsie. 1 mole of O2 is 32 grams of O2. Okay. Oops. So now what I want to do is, again, convert to the same product. What that means is I have to go to step 3 of stoichiometry in both cases. Then I can make a comparison. Okay. So the mole ratio, oh, I never balanced it, did I? So I need a 2 here and a 2 here. Okay. I'm sorry. Not there. We need it here. Okay, so 2 and 2 is my are the coefficients. Okay, so let's use our stoich. I have 2 moles of H2 on the bottom to 2 moles of water. Okay, now actually I'm going to switch this. I'm going to switch to a different color so you guys can see that I am converting to the same product. In this case, there's only 1 product to pick from. I know, but when there's 2, it must be the same product. So notice we have that as blue as our same product. Okay. Okay, so everything's been converted to water. So now what I'm going to do is do some quick calculations and figure out which one I end up with less product. Okay. So if I take 150 divided by 2, that's 75, times 1 is 75 moles of water produced when I consider 150 grams of H2. Okay? Now, if I take 1,500 divided by 32 times 2, I end up with about 93.8. So notice it was close. So which is my limiting reactant? It's the one that produces less product. And that's this one. This produced less water. So actually, I can ignore the excess reactant. I have too much of it. And the limiting reactant is going to give us all of our data. Okay? It's going to lead to all of our data. Okay? So we're not done yet. So usually these questions say, what's the limiting reactant? The answer is hydrogen is our limiting reactant. The next question might be, how much, and this one says, what mass of water can be formed? Okay, so what mass of water can be formed? Let's take our 75 moles of water, because that again leads to all of our answers. I know that 1 mole of water, you're back to 1 mole. This is step 4 of Stoic, by the way. And we're just going to multiply by 18, the molar mass. So I just went to step 4 of Stoic. So this is just applied Stoic, guys. 75 times 18 is 1,350 grams of water can be produced from these reactants in this equation. Okay? Let's do one more. Okay. Actually, I will save this one for class. Let's keep it short and sweet. If you have any questions, email me.